Hello guys, welcome back. This is me again, Ittehad from the Roots of Unity with the second video of quadratics. In our previous video, we saw how to solve quadratic equations. In this video, I'll show you guys how to sketch a quadratic equation. We know that a quadratic equation means the equation of a parabola, which means it is symmetrical about its turning point. In order to sketch a quadratic curve, we need to know three things about the curve: its x-intercept, its y-intercept, and its turning point, or known as vertex. X-intercept means the value of x for which y is equals to 0, which means the places where the curve cuts the x-axis. X-intercept is basically the root of the equation. As I have shown you in my previous video, roots can be found by using factorization, completing square, and by using the general formula. Similarly, y-intercept means the place where the curve cuts the y-axis, which means where x is equals to 0. In order to find the y-intercept of the quadratic curve with the equation y is equals to ax squared plus bx plus c, we need to put x is equals to 0 in the equation. This eliminates the terms containing x and x squared, and we get that the y-intercept is 0, c. Let's check out an example. Y is equals to 2x squared plus 5x plus 1. For this equation, the y-intercept will be 1. When x is equals to 0, y comes 1. So the coordinates of the y-intercept is 0, 1. All that is left is how to find the turning point or the vertex. A turning point is the point where the curve changes its direction. In a quadratic curve, if a line is drawn parallel to the y-axis passing through the turning point, it is seen that the line is the line of symmetry. It means that the curve is symmetrical on both sides of that line. The line of symmetry is often called the axis of symmetry. Well, before showing you how to find the turning point, let me tell you something. A quadratic curve can be of two types. One type is where the curve has a minimum point, where the coefficient of x squared is positive. This is where the curve looks like a smiley face, a happy face. And the other is where the curve has a maximum point, where the coefficient of x squared is negative. This is where the curve has a sad face, looks like a sad face basically. There are two ways of how to find the turning point of a curve. One is by using the completed square form of a quadratic equation, and the other is by using differentiation. Let's see the first way now. In the completed square form, we will express the equation y is equals to ax squared plus bx plus c in the form y is equals to a into x minus b whole square plus q. In this equation, the part inside the bracket can never be negative due to the presence of the power 2. This means that the lowest or highest value of y takes place when the part inside the bracket is 0. For a is greater than 0, the curve has a minimum turning point, for which the lowest value of a into x minus b whole square will be 0. And if a is negative, that means the curve has a maximum turning point. In that case, the highest value of a into x minus b whole square will be 0. So we will equate the part inside the bracket to be equals to 0. In the quadratic equation, y is equals to a into x minus b whole square plus q. X minus b is equals to 0. Therefore, x is equals to p. Now we will put the value of x in the equation, which will give us y is equals to q. So the turning point of the curve will have the coordinates p, q. From here, we can deduce that for any equation in the form y is equals to a into x minus b whole square plus q, the turning point is p, q. Now let us check out how can we find the turning point of the equation using differentiation. We know that the tangent of the quadratic curve at the turning point is parallel to the x-axis, which means that the gradient is 0. We also know that differentiating the quadratic equation gives us the equation of the gradient. So we will equate dy by dx equals to 0 and find the x coordinate of the turning point. And then we'll put this value of x in the equation to find the y coordinate. Thus we find the coordinates of the turning point using differentiation. Now that we know how to find the turning point, we just need to know one more little thing. Our curve can be of three types. 1. The curve has two roots. Number 2. The curve has only one root. And number 3. When the curve has no roots. Basically, the curve does not touch the x-axis. Guys, I'm going to tell you a trick now on how to save time while sketching a graph. Always find the turning point first. Let me tell you the reason now. Look in the graph where the curve does not touch the x-axis. If we know that the turning point is above the x-axis of a minimum curve, it means that the curve can never be 0 or negative, indicating there is no intercept. Similarly, if we know that the turning point is below the x-axis of a maximum curve, it means that the curve can never be 0 or positive. Doing this will spare us from solving the equation and disappointing ourselves by finding out that the roots are complex. There is another way to find out whether a root is complex or real. I will show that to you later in my next video. Make sure you see all the videos top to bottom properly. You will understand how easy quadratic equations are. Now that we know everything we needed to know about sketching a quadratic curve, let's draw these curves and clear our concept. I'll show you 3 examples where there are 2 roots, 1 root and no roots. Now let us check out how to sketch the graph y is equals to x squared minus 5x plus 4. It's very easy. We'll follow the steps. First, we find the turning point, for which we need to express our equation in the completed square form. From here, we can say that 5 by 2 and minus 9 by 4 are the x and y coordinates of the turning point. So the turning point is 5 by 2 minus 9 by 4. Since it is the minimum curve where the coefficient of x squared is positive and the turning point has a y coordinate which is negative, we know that there are parts where the curve cuts the x-axis. In order to find the roots, we will just factorize it in this case, since factorization is possible, and then we'll find that the roots are where x is equals to 1 and x is equals to 4. This gives us the coordinates 1, 0 and 4, 0 where the curve cuts the x-axis. Next, we will just put the value of x is equals to 0 to find the y coordinate, which will give us y is equals to 4. The coordinates are 0, 4. As I have told you before, since the coefficient of x squared is positive, the turning point is a minimum point, which means a happy face. Now let's first put the points 0, 4, 1, 0 and 4, 0 and the turning point 5 by 2 minus 9 by 4. Then we'll just join the points and draw the curve. Our next example is y is equals to minus x squared plus 4x minus 4. At first, we'll express it in the completed square form to find out the turning point. From here, the completed square form is y is equals to minus into x minus 2 whole square plus 0. From here, the turning point is 2, 0. Now, the turning point shows us that the curve is turning by touching the x-axis. In such cases where the turning point is at the x-axis, the turning point and the root is the same point basically. I have solved the equation here and saw that the result tells us the same thing. Now let us put x is equals to 0 to find the y-intercept, which gives us 0, minus 4. Since the coefficient of x squared is negative, the turning point will be a maximum point, which means the curve will be a sad-faced curve. Now let us put the values in the graph and sketch the graph. It will come something like this. Our last example will be y is equals to x squared minus 4x plus 5. At first, we'll express it in the completed square form and find x minus 2 whole square plus 1. From here, we can say that the turning point is 2, 1. Now, let's see one thing. The turning point is above the x-axis. And we already know that for a minimum curve, when the turning point is above the x-axis, there is no x-intercept. So we can just skip to that part and find the y-intercept. Here we put x is equals to 0 and the y-intercept comes y is equals to 5, so 0, 5. The point is a minimum point as the coefficient of x squared is positive. We already know that. Now we'll put the values and see, the curve goes something like this. That was all for this video. Stay tuned to learn the remaining parts, which includes a vital part of this chapter, the discriminant b square minus 4ac and what does it represent.